A small ball is projected from a fixed point O so as to hit a target T, which is a horizontal distance of 9a from O and at a height of 6a above O. The ball is projected with speed. We've been given speed here of square root of 27 ag and angle of theta to the horizontal. Right, and we've been asked to show that tan squared theta minus 6 tan theta plus 5 is equal to 0. Right, so this is a projectiles question. So the first thing you should do with a projectiles question is write down all the information you have. So SUVAT, SUVAT, and I'm going to take towards the right as positive and upwards as positive. So I've put those arrows in. Now I know in order to travel from where it started at O to hit the target T, it moved horizontally 9a and vertically 6a. Its initial velocity, its initial speed was root 27 ag. And we were told that it was projected at an angle of theta. So opposite the angle, we know that that is sine theta, and we know that next to the angle therefore must be cos theta. And this way, going this way. So the initial velocity in the horizontal direction is the square root of 27 ag. I just need to get cos theta. And the vertical direction is square root of 27 ag sine theta. Horizontal final velocity is the same as the initial velocity, and this is because the horizontal acceleration is 0. And vertical velocity, final velocity, we don't know. Well, however, we do know that the acceleration caused due to gravity is minus 9.8, or in this case I think we might end up using minus g, seeing as our speed is given in terms of g as well. And we don't know t. Now looking at the question, it says show that tan squared theta minus 6 tan theta plus 5 is equal to 0. You can't tell exactly which equation to use, but I'm going to go with s equals ut plus half at squared. Mainly because this way, in the horizontal direction, because there is no acceleration, I can just go with s equals ut. This would allow me to find t and sub it in to my vertical direction when I get there. So horizontally, s is equal to 9a. The initial velocity was the square root of 27 ag cos theta, and t is t. As said, from here we can make t the subject to give us 9a over the square root of 27 ag cos theta. Now let's look at the vertical direction. In the vertical direction, we use the same equation again. And vertically, the initial the displacement was 6a. Initial velocity was the square root of 27 ag sine theta times by t plus a half, and then a was minus g and t squared. And as we've found t in terms of cos theta and a earlier, So we're going to sub that into this equation now. What do we get? We get 6a is equal to the square root of 27 ag sine theta times by t over the square root of 27 ag cos theta. It's minus g times a half, so that's minus g over 2 times by t squared, which is 9a over the square root of 27 ag cos theta all squared. So we need to simplify each of these terms. So we've got 6a is equal to the square root of 27 ag can cancel, and then sine theta over cos theta gives us tan theta. So we've got 9a tan theta, and this is starting to look a lot like we wanted. Alright, let's look at the next term. We've got g over 2, and then 9a squared is 81 a squared, and if we square the denominator we can get rid of this square root sign. We get 27 ag cos squared theta. Now simplifying each term, let's look at this bracket over here. If we can cancel a's, so we've got an a squared at the top and an a at the bottom, so we're left with a at the top and 1 at the bottom. We can cancel g's, and then the 81 over 27, well, 27 goes into both, so that leaves us with a 3 there and a 1 at the bottom, and that seems to work out quite nicely. So we're going to get 6a is equal to 9a tan theta minus, we've got half left on the outside, on the inside we've got 3a in the numerator over cos squared theta. Now we wanted a quadratic in tan, so we need to somehow change this cos squared theta. Instead of writing it as divided by cos squared theta, we could write it as sec squared theta. And this is good because we know that there's an identity for sec squared in terms of tan squared, namely that sec squared theta is equal to tan squared theta plus 1. So let's put that in there. Expand that out. Now I need to get rid of all these a's, so we could divide everything by a, so they can all go, and let's times everything by 2. And take everything to one side. And divide by 3. Giving us what we wanted. So let's just put a little as required. Here we find the two possible angles of projection. The two possible angles of projection are theta 1 and theta 2, where theta 1 is bigger than theta 2. Find tan theta 1 and tan theta 2. So we had our quadratic. Let's factorize our quadratic. You can use a substitution y is equal to tan theta to help you factorize this, or you can factorize it just like that, and we get tan theta is equal to 5, or tan theta equals 1. Now which one is theta 1 and which one is theta 2? Well, we're told that the angle for theta 1 is bigger than theta 2. And if we look at our tan graph, if tan theta equals 1 and tan theta equals 5, then tan theta of 1 must be theta 2, because that is smaller. Theta 2 is smaller than theta 1. So we can put that this is tan theta 2 and this is tan theta 1. Note that the particle is projected at the larger angle, so theta 1, so we can write down that tan theta of 1 we knew was 5. Show that the time of flight, O to t, is square root of 78a over g. We knew that t was equal to 9a over the square root of 27 ag cos theta, and this is in our working for part A when we did the horizontal equation for S. Now that we know that tan theta is equal to 5, we can draw our right angle triangle. Tan theta is equal to 5. That means that the opposite over the adjacent, the ratio between the opposite and the adjacent, must be 5. The simplest way to do that is put a 5 and a 1 there. So the hypotenuse must be root 26, and so cos theta of 1 must be equal to adjacent over hypotenuse. And we can put that in. So we've got 9a over the square root of 27 ag, 1 over root 26. If we bring the 1 over root 26 to the top, so if we times top and bottom by root 26, we get 9 lots of root 26 times by a over square root of 27 ag. Now if we simplify our third at the bottom, we get 9 root 26a divided by 3 root 3, as root 27 is root 9 times root 3. So, and we get square root a square root g. 3 and 9 will cancel, leaving you with the 3 at the top, and an a and square root a will leave you root a in the numerator. So let's just think about it. Let's just rewrite that now. Get 3 root 26 root a divided by root 3 root g. And bearing in mind that we want the square root of 78a over g. So I'm just going to write that over here to remind me. So I don't want any square roots at the bottom, so maybe I should times by root 3 over root 3 and get rid of that third. And so that works out quite nicely, because root 3 times root 26 is 78 root a over 3 root g, and we can cancel the 3's, leaving us with square root of 78a over g as we needed.